Good morning, everyone. This is Mrs. Robinson, or good afternoon, depending on when you're watching this. This is day 2 review of exponents and radicals. So we did square root, we did exponents last time, we did systems of equations, and now we're moving on to radicals. So a lot of simplifying today, so then we can get used to it, and then we will be graphing these in the future. Okay, so here are the properties. So product property of radicals. So if they are together, you can separate them and vice versa if it helps. Same with quotient. They can be under one radical or they can be separate. Again, if that helps with simplifying. And then the last one is about combining like terms. So if you have the same radical, you add the coefficients in front, okay? So if I had 7 plus 4, that's 11 root 3, because they both have root 3 as the same radical. All right, moving right along. So use properties of exponents to solve these. So I'm going to be adding these exponents, but they need to have common denominators. So instead of 1/2, I'm going to write 3/6. So it's important in your notes. Oops, we need like terms, Miss Robinson. 1/2 would become 2/4. So sorry, times 9 times to the 3/4. So I know these videos can be daunting. It's a lot to do on your own, but please make sure to show your work. It's so hard to go back to your notes and say, how did I get that answer? Unless you have that work. So 2 plus 3 is 5, so 9 to the 5/4. You could also write it in radical form. Again, this is the root, and that is the power. So it could be 4 root 9 to the 5th. Woohoo! 4 root 9 to the 5th. Okay, so you could also write it that way. So those are the two different ways. All right, so number 2, if you have 5 root 27 and 5 root 9, based on our property of radicals, I'm going to put them under the same radical and see if I can take anything out. Okay, so it seems kind of silly, but what I do is I branch out and see if I can find 5 of something. So 27, 9 and 3, 9 is 3 and 3. What goes into 9? 3 and 3, and look at that. Now I have 1, 2, 3, 4, 5. Okay, so the root of 5 root 27 times 9, the answer is 3. Now, if you want to put it in the calculator to see if it goes in evenly, it's rather rare, but if it does, this is what we will do. So we have this math button, okay? So in the top left corner of your graphing calculator, so you have the 1, so fraction decimal. If you want to cube, to the 3rd power, if you want to cube root, and then we have this number 5, which is x root, okay? So what I would do is I press 5, then I'd go up to this math button, scroll down to that, and then if you notice, the 5 becomes the root. And then you can do 27 times 9 inside equals 3. Okay? So that is also the case. If you wanted to, let's say I have to put something to the 5th power. So if I did 15 to the 5th power, okay, so this upside down V under the clear button makes an exponent, and then you can get some crazy answers that way too. Okay, so math button number 5, if you need something other than square root or cube root, there's your button. And then if you need to put a power to something, that's upside down V, I call it, under the clear button. All right, so just help with the calculator. All right, the last one on this page, so 42x to the 4th, z to the 7th, and 6x to the 3/2, y to the -3rd, and z to the 5th. Holy mama jamba. All right, so I'm going to actually make this a little bit bigger so we can see what to unpack it. All right, so I have 42 over 6, so I'm going to deal with that first, and that answer is 7. Okay, now I'm going to deal with the x's. So x to the 4th over x to the 3/2. Now I need to make common denominators because I need to subtract the exponents. Subtract is quotient power, okay? So instead of writing 4, I'm going to write 8 over 2. So now I have common denominators with the common denominators. Okay, so 8 over 2. So 8 halves minus 3 halves becomes 5 halves. So now I have x to the 5 halves on the top. There we go. All right. The next one, let's deal with the y to the negative third. Well, if you had y to the negative third in the denominator, how do I make it positive? I'm going to bring it to the top. It doesn't have anything to simplify with, so I'm going to move it to the top to simplify. That's the only thing I can do. Z to the 7th over z to the 5th, well, 7 minus 5 is to the 2nd power. So now this is my answer, okay? If I had z to the 5th over z to the 7th this way, well, what's 5 minus 7? Well, that is negative 2. How do I write that? 1 over z to the 2nd. All right, so how I try to do it is, okay, what do they have in common? They have 5 in common. What's left over? 2. So z to the 2nd is in the denominator. Okay? All right, moving right along. So 4, 5, and 6, let's work on those. So for number 4, I need to, again, make common denominator. So instead of 1/3, I want to write 2 6. Okay, and then I have 3 over 5 to the 6. They have the same base, so then I can subtract. So I can subtract the exponents. That's supposed to be a 5. There we go. So 5 6 minus 2 6 is 3 6, and that can be reduced to 1/2. And then you can write it, again, in radical form, the square root of 3. Okay, so either way, you can write that. All right, the next one. If you notice, a squared b to the 1/4, a squared b to the 1/4, holy cow, those are the same. So therefore, I'm going to combine the coefficients because it's like terms. So 3 plus 4 is 7, a squared, b to the 1/4. There we go. And if it's not written that way, let's say it's like a multiple choice situation. Another way to write the 1/4, so I could say 7a squared and then 4 root b. So that's another way it could be written if it's not written the other way. All right, so 5 root 128. So what you could do is plug it into the calculator and see if it goes in evenly. Okay, so here we go. 128, 8, and it gives me a crazy answer. So this is what I do. So 128, what goes into 128? Okay, well, I know 2 goes in, it's even. Let's see if 4 goes in. Okay, wow. Well, we could even go even further. What about 16? All right, so what goes into 128? 16 and, sorry, it goes away. 16 and 8, all right? Then I'm going to keep unpacking. Okay, so 4 and 4. 8 is 4 and 2. 2 and 2. So I'm going to keep going until I get prime numbers. All right, and then I need 5 of something in order for it to come out of the radical. So I have 1, 2, 3, 4, 5. I have a set of 5. So I take out a 2, and what do I have left over? I have 2 2's left over. So I have 2, 5 root, and then 2 times 2 is 4. Woohoo. So I have 2, 5 root 4. Okay? So before I had, so if I wanted to do math, so I have 5, math, 5 root 128, boop, 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 boop. And that's what I get as my answer. And then this is a way for you to check that you solved it correctly. Okay? So 2, then 5 math, like that. Woohoo! I don't want 25. So I'm just going to do 5 root, there we go. And then 4, and then I'm going to times that by 2. And look, I get 2.63 and 2.63. So you can see that you simplified because you should get the same answer. Okay? All right. So I want you guys to try 7, 8, and 9 on your own. I want you to branch out and see how you would solve that. Number 7, you need to multiply this 3 to each of those exponents, and then if you can see if you can simplify from there. Again, they don't have the same base, so I can't put those together first. So I'm just multiplying the exponents. Number 8, can you branch out and see what comes out? And the same with number 9. What can you make groups of 3 and then simplify from there? So your answers. So number 7 should be 49 root 5. Number 8, 2x to the third. And number 9, 6 cube root 12. Okay, so trying those out and seeing, and then ask us questions in class if you need to. All right, number 10, 11, and 12. Okay, so number 10. This is a lot to look at, okay? So what I notice is that I'm going to see if they have the same info in there. So what I could do is I could do 16 squared and then cube root of that over the cube root of 4 squared. Okay? They have the same radical. Now remember, it's all to the 4th power. So number 10 is pretty intense. Okay. So now I'm going to put them under the same radical. Woohoo! So 16 squared over 4 squared. And see if I can simplify that. Woohoo! Sorry, I keep making those noises. All right. So I'm going to try to simplify that and deal with the radical before I have to put it to the 4th power. All right, so if 16 squared divided by 4 squared, that answer is 16, okay? And then I have it to cube root of 16 to the 4th power. So how could I rewrite that? Well, my power is 4, my root is 3. So my power, so the power is on the top, the root is on the bottom. So you could rewrite it like this. 16 to the 4/3. Okay, so you could rewrite it. So either way should be fine for your final answer. But if they ask you to put it in radical form, or if they ask you to put it in exponential form, you can kind of switch that up. All right. Okay, number 11. Again, they have the same radical, 4 root 6. So what do? I add the coefficient. 6 plus 2 is 8. So I have 8, 4 root 6. And that's it. Okay, number 12. Can I simplify inside the parentheses? I cannot. So I'm going to split it up. Okay. Now, this is the tricky part. I need to get rid of the radical in the denominator. Okay, so how do I do that? So I need 3 of something in order for it to come out of the bottom. Right now I have, well, what goes into 9, 3, and 3? So I need another 3 in order for me to be able to get rid of the radical in the denominator. Okay, I want to get rid of the radical. So if I times everything by 3, if I times it by 9, I still won't get rid of it. Okay, again, I need 3 of something in order to get rid of a cube root. So 5 times 3, that's 15. And on the bottom, 9 times 3 is 27. Okay? Now, I did that because what goes into 27? 9 and 3, and then 3 and 3. So, the cube root of 27 is 3. All right? And then the numerator, I can't take anything out. So then this is my final answer. Some people might ask, well, 15 and 3, I can take a 3 out. No, the 15 is inside the radical, and 3 is not. So that's why you can't reduce there from any more. Let's say, for example, I had 1 over cube root of 7, okay? Well, what would I need to do? I would need 2 more 7s in order to get rid of the radical. So you need to look at the denominator and see what else do you need in order for it to go away, okay? Whether it's a square root or a cube root or a 4 root. All right, so you guys are going to try 13, 14, and 15. Okay, number 13. Can you simplify 4 root 48 and see then if you can combine like terms with the second one? Number 14. You need to look at the exponents and see how would you subtract that. And then number 15. Can you put this under the same radical and then simplify? All right, hopefully you tried these out, please. And then these would be your final answers for those 3. All right, we're almost there. So we're going to work on the next ones. These are a little bit more hefty, and then we will be done for today. All right, 16, 17, and 18. Here we go. So number 16, again, I'm going to put them under the same radical to see if I can simplify before I have to start multiplying things. So 192 divided by 3 is 64. So I have the cube root of 64. Okay, well, I know what the cube root of 64 is. If you don't, again, you can branch out. Well, 64 is 8 and 8. Oh, no, it needs to be cube root. Oh, man. Okay, so 8 would be 4 and 2, 4 and 2, 2 and 2, 2 and 2. All right, so then I have two groups of 3s, so I can take them out. What's 2 times 2? Well, that is 4. So your final answer would be 4 for that one. Okay? Again, groups of 3. If you knew what the cube root of 64 was for, that's awesome also. Okay, number 17. So I need to multiply this 1/2 to everything on the inside. Or you can make it into a radical. What this means, the 2 is the root. The 1 is the power. Okay, so the square root of 36, m to the 4th, n to the 10th. So the square root of 36 is 6. M to the 4th. Well, how many groups of 2 is that? 1, 2. That's 2 groups. And n to the 10th, how many pairs do you have in n to the 10th? Let me write it real quick. I'm kind of a visual person. So 1, 2, 3, 4, and 5. N to the 5th. And that would be your final answer. Okay? You could also have multiplied everything to the 1/2. Well, what is 4 times 1/2? Well, that is 2. And what's 10 times 1/2? That is 5. And what's 36 to the 1/2? That is 6. So there's more than just one way to rock this out. Woo-hoo. Let me move this back up so you can see it. There we are. Okay. Power and root. Perfect. All right, number 18. So there's nothing with a squared and b to the 6. There's nothing I can simplify, so I'm going to break it apart. So 5 root a squared over 5 root b to the 6th. All right, let's think about this denominator, because that's what matters. I want to get rid of the radical in the denominator. Okay, so, all right, I need a little bit more space. Sorry about that. All right, so 5 root b to the 6th. Okay, do I have 5 b's? Yes, I do. I have 5 b's, so I can take that out. And now I have 1 b left over. Okay, so I simplify the denominator, and then I can see what's up. All right, so how many more b's do I need in order to take out that final b? It needs 4 partners. It has 1 b. I need 4 more. Okay, so I need to multiply the top and bottom, the numerator and denominator, by 4 root b to the 4th. Okay, as weird and funky as that is. Okay, so 5 root b. All right, so now I'm going to multiply. So 5 root a squared b to the 4th in the numerator, and in the denominator I have b, remember that b on the outside, 5 root b to the 5th. Okay, so it's like it cancels out. So it's like if I wanted to rewrite this, it's like if I had b 5 over 5, because the power is 5 and the root is 5. Well, how do I reduce 5 over 5? Well, that's just 1. Okay? So that's kind of what I'm trying to get to. All right, so instead of writing b 5 root b to the 5th, I now have 2 b's. So b times b, and that's b squared. Okay, I can't take anything out of the numerator, so I just kind of leave it like that. What is my mission? To get rid of the radical in the denominator. I know these videos are getting longer and longer, guys. Hang in there with us. You know, in the future, these notes are pretty hefty. There's a lot going on. So we have 3 more, and then we are done for today. So just hang in tight. All right, so I have 324 to the 1/4 and 2 to the negative 1/4. Big indicator. So I have 2 to the negative 1/4. We need to bring that to the numerator to make it positive. So now I have 324, 1 to the 4th, times 2 to the 1/4. Well, we can make them both go into the radical of 4 root 324 times 4 root 2. And now that they're both, if they both have the same radical, I can put them under the same, if they both have 4 root, now I can put them under the same radical and see what I can do. Can I take anything out of 324 times 2? So I branched out 324 to see if there's any groups of 4. And there's 3 2s, which is not enough, but there are 4 3s. So bada bing, I can take out a group of 3s, and then I have 4 root 2 times 2 times 2 is 8. So that would be my final answer for number 19. Okay, number 20. All right, number 20. So I'm going to break this apart. So 3 root a to the 9th over 3 root b to the 6th. And this is quite nice because how many groups of 3 do I have for a to the 9th? I have 3 groups. And how many groups if I have 6 b's and I'm doing a cube root? Well, I have 2. So my final answer would be a to the 3rd over b squared. So I don't have to multiply anything to the numerator and denominator to get rid of the radical. It just works out quite nicely once I break it apart. All right, the final one. So cube root 8x to the 7th, y to the 3rd, z to the 11th. So this is all about making that groups of 3. So if I have cube root of 8, that is 2. X to the 7th. How many groups of 3 do I have? I have 2 and 1 left over inside the radical. So let me make that cube root of a radical so then I can see what's up. Okay? And then let me move this because we're going to have more stuff on the outside. All right, so what gets to come out of the radical? What has to stay in? So 2 gets to come out. I get to bring out x squared because I had 2 sets of 3's. And then y to the 3rd, that means I get to take out a y because I have 1 group of 3's. And then z to the 11th. All right, well, how many groups is that? Well, that's 3 groups. 3 groups, and then I have 2 left over. So then that is my final answer. Again, how did I get used to this? Sometimes you just have to write them out. Y to the 3rd means I have 3 of them. So then I have 1 group of 3's. So sometimes you just kind of have to work it out. All right, so thanks so much for joining me today, and I hope you guys have a fabulous day. Goodbye.